Alright, we are going to solve this rational equation. So to do that, you know what? I think I want to get rid of this negative sign before I even get started, because that's the biggest problem students have, is what to do with this negative sign when you subtract. So sometimes I think it's easier just to get rid of it right from the start. So I will do that by changing this to a plus and then distributing the minus sign. So I will make this a minus 2n, and I will make this into a plus 16. Alright, so now I've dealt with the minus sign. Whoops, except for it disappears. Now I've dealt with the minus sign, so now I can proceed with the problem just like an addition problem, any other addition problem. So let's do some factoring here, because really I want to make the denominators be the same, but I need to see what I'm dealing with. Okay, so GCF, I see a common factor of n, so that's going to leave n times n plus 8. And this is the same thing. Okay, so I just need to make all the denominators the same. So these two denominators are already the same, with n and then n plus 8. So this denominator just needs an extra n, which I can do as long as I put another factor of n in the numerator. Now the denominators are all the same, so I can cross out these denominators. But real quick, let's talk excluded values. N cannot equal 0. N cannot equal negative 8. Alright, because of the n and the n plus 8, set that equal to 0, you get negative 8. Alright, can't divide by 0. So now that the denominators are the same, I can cancel those denominators out and make a new equation using the numerators. So n equals 1 plus negative 2n plus 16. Okay, I see like terms with the 1 and the 16, so I have negative 2n plus 17. I'm going to add 2n to both sides, bringing these together, so that makes 3n is equal to 17. Dividing both sides by 3, I get n is equal to 17 thirds. And that is not one of my excluded values, so this is the answer. Okay, 1 down, 4 to go. Alright, let's find problem number 7. And there it is. There she blows. Let's see, a little bit of factoring to do. So let's make it happen. So I have 3 over 5x plus 6. Nothing to factor there. Here's where that small amount of factoring comes in. I have 7. I see a common factor of x. So I'm going to bring that x out, GCF, and that will leave behind 5x plus 6. Alright, and of course this is the same thing as the other denominator. So again, I'll have x and I'll have 5x plus 6. Now the name of the game is make the denominators the same. Yeah, I noticed that rhymed. I'm just accidentally awesome like that sometimes. So to make the denominators the same, all I need to do is put a factor of x right here. Which is valid as long as I put an x in the numerator as well. Before I cancel out these denominators, which I am going to do, now would be a good time to say the excluded values. X cannot equal 0 because of the x here, and x cannot equal negative 6 over 5. Alright, these are excluded. I'm getting the negative 6 over 5. If you take 5x plus 6 and set it equal to 0 and solve, then you get negative 6 over 5. Anyways, I can cancel out these like denominators and make a new equation out of the numerators. So that'll be 3x plus 7 is equal to 4. Okay, pretty simple equation to deal with. So subtract 7 from both sides. So that'll give me 3x is equal to negative 3. Look at that. When I divide both sides by 3, I'm going to just get x equals negative 1. And that is not one of my excluded values, so that is the solution. Alright, 2 down, 3 to go. Let's find number 8. Okay, alright, it's close I'm going to get. So factoring, alright, this is really similar to the last problem. So I have 5 over x right there. I think I'm going to do like last time. See this negative? I'm going to go ahead and put it up here on the 1. So I'm going to make this a plus, put that negative up here immediately. Okay, immediately, people. So there's that negative 1 now. There's a common factor of x. So if you pull out the GCF, that's x times x minus 2. This is identical, so again it'll be x times x minus 2. So now is a good time to say the excluded values. X cannot equal 0 because of the x, and x cannot equal positive 2 because of the x minus 2. Alright, so just make sure that none of your solutions are one of these. To solve this, let's get all the denominators the same and cancel them out. Notice all the denominators have an x, but this denominator is missing the x minus 2 that the rest of them have. I can just write it in as long as I put x minus 2 in the numerator as well. Now the denominators are the same. I can cancel them out and make a new equation from the numerators. I am going to go ahead and distribute this, so that'll be 5x minus 10, and then there's that negative 1 is equal to x plus 5. Negative 10 and negative 1, that's negative 11, so I have 5x minus 11 is equal to x plus 5. I am going to subtract x from both sides, so that's 4x minus 11 is equal to 5. Now I will add 11 to both sides. So that is 4x is equal to 16. And then now I will divide both sides by 4. So x equals 4. So that is the solution as long as it is not excluded. Alright, that is not one of the excluded values. So there you go, x equals 4 for number 8. Okay, 2 more problems to go. Let's find number 9 and number 10. Oh, there it is. Alright, last 2 problems. Okay, again, I will prefer to move this negative sign immediately. So I'm going to make this a plus and put the negative sign up here. Now I just don't have to worry about it. Alright, I recommend you do the same. So I'm just going to recopy and factor as I go. So this needs to be factored. Yeah, so I've got this negative 2 up there. K squared minus 1, that is the difference of 2 squares. So that is k plus 1 k minus 1. And of course this is the same thing. K plus 1, k minus 1. Alright, let's make all the denominators the same. But wait, now is a good time to say the excluded values. Because of the k plus 1, k cannot equal negative 1. Alright, because of the k minus 1, k cannot equal positive 1. So these are my excluded values. Now, let's make the denominators the same. All of the denominators have k plus 1. But these two have k minus 1. So this denominator needs a k minus 1. I can do that as long as I put k minus 1 in the numerator as well. Now my denominators are the same, so I can cancel them out and make a new equation from the numerators. So this is k minus 1 plus negative 2 is equal to 3. That's an awfully simple equation. Negative 1 and negative 2, well, that's negative 3. Let's add 3 to both sides. So k is equal to 6. And that's the solution because it is not one of the excluded values. So that's it for number 9. Okay, one last problem, number 10. So again, I'm going to go ahead and deal with this minus sign immediately. So I'm going to turn this into a plus and put the minus up there. So let's see, I have 7 over n equals. I'm not going to bother factoring the numerator, so I have 2n minus 4. Now, I see the GCF down here, common factor of n, so that will become n and then n minus 4. Plus, right, I made this plus, remember? And these are identical, so again it's going to be n and then n minus 4. So let's make the denominators the same. But hey, first let's say the excluded values. Because of the n cannot equal 0, can't divide by 0. Because of the n minus 4, n cannot equal positive 4. So these are my excluded values. Alright, what was I doing? Oh yeah, I was making the denominators the same. All of the denominators have n. These two have n minus 4, which this doesn't have. So I can go ahead and put n minus 4 as long as I put it in the numerator and the denominator. Now all the denominators are the same, so I can cancel them out and make a new equation using the numerators. I'm going to go ahead and distribute this. So I have 7n minus 28 is equal to 2n minus 4 plus negative 1. Let's see, like terms. So I have 7n minus 28 is equal to 2n. Negative 4 and negative 1, so that's negative 5. I'd like to get these n's together. So I will subtract 2n from both sides. My n's are starting to look like h's again. Anyway, 7n minus 2n, so that'll be 5n minus 28 is equal to negative 5. Let's add 28 to both sides. So I've got 5n equals 23. Yep. And so then when I divide both sides by 5, I get n equals 23/5. And as long as that's not one of my excluded values, we're good. Okay, and it isn't. So that's it. 23 over 5. And that's going to do it for this video, people. I hope it was helpful. See you around.